In this tutorial, we are going to solve more examples in order to learn how to integrate simple function of the form f of x equal ax power n, where n is a real number and a is a constant. Let's go back to the definition on page 134. We already know if dy by dx equal x power n, then y equal 1 over n plus 1 multiplied by x to the power n plus 1 plus a constant, and n should not equal to minus 1. This is a condition that we must have always. Why n is not supposed to be equal to minus 1? If we try to take 1 over n plus 1 and take instead of n minus 1, then 1 over minus 1 plus 1 is 0. 1 over 0 is an undetermined number. That's why we avoid taking n equal to minus 1. So we continue having this condition as long as we are working with this formula. Also, we know if dy by dx equal constant multiplied by x power n, then y equal constant divided by n plus 1 multiplied by x power n plus 1 plus constant c, where n also does not equal to minus 1. For better understanding now, we are going to move to set of exercises 8a, page 135, and we are going to take different examples or exercises to find the expression for y when dy by dx is as follow. Let's take part 17. We have minus 3 x to the power minus 2 over 3. Then, based on the formula, we can identify the given. We have minus 3 multiplied by x to the power minus 2 over 3. Then, now we can say that minus 3 is the constant k, and minus 2 over 3 is n. Therefore, n plus 1 equal to minus 2 over 3 plus 1. This is equal to plus 1 over 3. Therefore, we can substitute now in k over n plus 1 multiplied by x to the power n plus 1 plus a constant. So we get the integration for dy by dx. So it becomes as minus 3 divided by minus or plus 1 over 3, that is n plus 1, multiplied by x to the power n plus 1, that is 1 over 3, plus a constant. If we take 3 over 1 over 3, then it's going to be minus 9 multiplied by x to the power 1 over 3 plus a constant. As you observe, we identified all the terms that we have to be able to find the value. In part 18, we have dy by dx equal to minus 5. This is only a constant, but we can think about it as multiplied by x to the power 0. Why? Because x to the power 0 is equal to 1. Then minus 5 multiplied by 1 is minus 5. It's the same. When we have a constant, then we multiply it by x to the power 0. And then k is minus 5 and n equal to 0. Therefore, n plus 1 is 0 plus 1 equal to 1. We substitute therefore in y equal to k over n plus 1 multiplied by x to the power n plus 1 plus a constant. This is equal to minus 5 divided by 1 multiplied by x to the power 1 plus c. This is equal to minus 5x plus c. So in this exercise, it's important to remember whenever we have a constant alone without any variable, then we can multiply it by 1, which does not make any difference, and 1 stands for x to the power 0. So we can take n equal to 0. Therefore, it's important to have this value next to the constant so we are able to integrate. Now, let's go to exercise 20. We have 2x to the power minus 0.4. Then dy by dx is 2x to the power minus 0.4. 2 is k, the constant, and n is 0 or minus 0.4. Therefore, n plus 1 is minus 0.4 plus 1 equal to 0.6. Therefore, y equal k over n plus 1 multiplied by x to the power n plus 1 plus c. By substitution, it's equal to 2 over 0.6 multiplied by x to the power 0.6 plus a constant. We can rewrite 2 over 0.6 as a fraction where 0.6 is 6 over 10 multiplied by x to the power 0.6 plus c. This is equal to 10 over 3 multiplied by x to the power 0.6 plus c. As long as the power was given in decimal point, so we can keep the decimals in the answer. Therefore, you can see how it was easy to solve the examples by applying the formula straightforward by identifying k and n value. Not to forget that when we have 1, 1 is x to the power 0. As a student, you can go and try the rest of the exercises.